Fifth grade, welcome to Tuesday's class. All right, let's do some practice together. Please pause the video and come back when you've attempted numbers 1, 2, and 3. See you soon. Hey, how was it? All right, let's look at number 1. It says the ratio of x to y is, and they use a colon and also a fraction bar. So we just have to look at the model that they give us. So x is the first term and y is the second term. That's the order that they give us. And we see x is 2 units and y is 7 units. So it's 2 to 7 or 2 to 7, right? Where in the fraction form, with the fraction bar, the ratio is written with the first term in the numerator and the second term in the denominator. Let's look at number 2. X is how many times y? Okay. Well, for that one is x is 2/7 times y. Do you guys remember why it's that? Okay, it's because in yesterday's lesson, when we have a sentence written as something is what times something else, that first value that comes before the is, okay, correlates to the numerator in the fraction, and then the last part of the sentence, that um, topic, or in this case y, that comes after the word times, correlates with the denominator of the fraction. Okay, and let's see why. Okay, because if we see here, okay, let's see, x is 2/7 times y. So I'm going to try to understand this to see why it's true. Okay, so x is just x. Is means I'm going to just write it as an equal sign. 2/7, I'm going to keep it as my fraction. Times, I'm going to write a multiplication sign. I wrote a small x because I have two x's here. So this, I kind of wrote it as like a curly x. Or tried to write it as a cursive x, I guess. But here I just wrote a tiny small x to show multiplication. That is a math operation. And y in this case is 7 because in the model is 7 units. Okay. Now here in the model, x here is 2 units, right? Okay. So I want to know, does 2 equal 2/7 times 7? Okay. Let's check it out. Okay, and let me just make my video screen a little bit bigger since we are, I'm doing some work on the board, on the whiteboard, okay? So here, we're going to see, does 2/7 times 7 equal 2? Okay, well, I have a fraction and I'm multiplying it by a whole number. So what I'm going to do is I'm going to change this whole number into a fraction by putting 1 in the denominator, okay, because 7 wholes is the same thing as 7, okay? So let's see. Once I have that, what I need to do at the bottom here is, now I'm going to multiply my numerators, and then I'm going to multiply my denominators. So 2 times 7 divided by 7 times 1, okay? And in this case here, okay, so you can do it a couple ways. You can cross it out, okay? Cross the common factors out, because I see a 7 here and a 7 here like this, okay? And then that'll become just 2/1, which will become 2. So, oh, it does work, okay? Or you can simplify it. You can simplify the numerator and the denominator. But it's easier if you cross it out, okay? Because you can simplify faster, okay? So then this would become 14/7, and this simplifies to, you can divide numerator and denominator by 7, 2 wholes, and that simplifies to just 2, and that works too, okay? So that's why number 2 is true. X is 2/7 times y, okay? All right, so for number, I'm just going to put this on the ground. All right, so for number 3, y is what fraction times x? And it's 7 halves times x, okay? And again, if you want to work it out, we can just do one more, okay, to just try to figure out what this means, okay? So y is 7 halves times x, okay? So here y, in this case, is 7 units, so I'm going to write 7, I'm going to write an equal sign. 7 halves, I'm going to write 7 halves, times, I'm going to write the multiplication operation x, and then for times, and then x is, if I look at the model, is 2 units. So the 7 equals 7 halves times 2, okay? And it does, because I'm going to change this whole number into a fraction, then I'm going to multiply my numerators together and my denominators together, and I'm going to do the cross-out method. These factors cancel out, okay? So then this becomes 7 wholes, can you see? Which is equal to just 7. And 7 is equal to 7, okay? And so this works, okay? All right. So just in the future, now that you know why it works, okay, what you can do is you can just follow that pattern of, when it's written as something is what fraction times something else, you can follow that pattern where something is, and then just put that in the numerator, and then times something else. That's something else you can put in the denominator, okay? But it has to be written in that form, okay? Something is times something else, okay, for that to work. All right, so you've got this. Let's keep going. Okay, so let's do practice numbers 4 through 8. Pause the video and then come back when you're ready. Hey, you must be ready. Okay, so let's look at the problem. The ratio of the length of pole A to the length of pole B is as represented in the model. The length of pole A is 4 units. The length of pole B is 5 units. Okay, so it looks like pole B is longer than pole A. So number 4, find the ratio of pole A's length to the length of the 2 poles. Okay, so write it in fraction form. All right, so then what's the total length of the 2 poles? Is pole A plus pole B, which is 4 plus 5, which is 9. Okay, so that would be 4 to 9. Okay, again, the first term is in the numerator, and the second term is in the denominator when we write it in fraction form with the fraction bar. The ratio in fraction with the fraction bar, I mean. Okay, let's look at number 5. How many times pole A's length is pole B's length? So we have to be careful how we're going to answer this question, okay? Because we want to answer it in the form that we saw before. Something is a fraction times something else, okay? So if this question is asked, how many times pole A's length is pole B's length? Then you would start your answer as pole B's length is something times pole A's length, right? That's the form, okay? So in shorthand, I just wrote B is something, a fraction times something else, A, okay? So that means for here, B, I have to write it where? In my numerator. And A, I have to write it where? In my denominator, okay? So if I look at the model, let me see, what is B? B is 5 units. And what is A? A is 4 units. Okay? So B is 5/4 times A. And that's true because B is longer than A. And 5/4 is an improper fraction. Okay, so I know it's bigger than 1. So when I multiply a value, whatever A is, that's bigger than 1, that amount is going to get bigger, right? So that means B is longer than A. Okay? All right. Next, okay, let's look at number 6. how many times pole B's length is pole A's length? So how do we start to answer our question? We'll say pole A's length is fraction times pole B's length, okay? That's how we would answer it, right? So again, something is a fraction times something else, okay? So again, A, let me see, how many units is A? And we're going to write it in the numerator. How many units is B? We're going to write it in the denominator. A is 4, B is 5, okay? And so A is 4/5 times B. Ta-da, like that. All right, let's look at number 7. Okay, how many times pole A's length is the total length of both poles? So we're going to start our answer as the total length of both poles is something times a pole A's length, right? So that's how we would answer our question verbally. And so in shorthand form, I just wrote this. Total is a fraction times A, okay? So, what is the total? Okay, well, the total of both poles is A plus B, which is 4 plus 5, which is 9. Okay, and then what is A? A is 4. Okay, so the total is 9/4 times A. Okay, that's what it says behind my video screen. All right, let's look at number 8. Okay, how many times pole B's length is the total length of both poles? All right, so how would we answer this? We'll start our answer off as the total length is a fraction times B, okay? So, yeah, this is how I would word it, okay? And I know that total has to go here in the numerator, and B has to go here in the denominator, and the total is 9, and then B is 5, okay? So the total is 9/5 times B, which is what it says behind my video screen. All right. How are you doing in your understanding? I think you guys things are getting clearer and clearer as we practice more, right? That's what I'm sensing in video land. Yeah. And if you have any questions, please ask me during our video session, and we'll make some time to tackle those questions. I'm proud of you guys just sticking through it and trying your best to understand and applying what we've been learning. All right, our last set of questions, okay? Let me just decrease my video screen a tiny bit so you can see. Okay, there we go. All right, so Jessie has $15. Kimberly has $21. I want you to do this on your own, so pause the video and come back when you're ready. Hey. All right, number 9. Find the ratio of the amount of money Jessie has to the amount of money that Kimberly has. Give your answer in fraction form. So we have to do Jessie as the first term, Kimberly as the second term, but in fraction form, Jessie is the first term, so it's in the numerator. Kimberly is the second term, so it's in the denominator. So it is 15 over 21. But the thing is, it's not simplified. Okay, remember, it's always customary to simplify fractions and ratios. So what we want to do is we're going to divide it by a common factor of 3, and then we get 5/7. Okay, now in this case here, okay, let's look at the simplified ratio 5/7. Okay, all right. So 5 refers to whose amount? It refers to Jessie's amount. Okay, so Jessie. Okay, and what about the 7? It refers to Kimberly's amount. Okay, all right. So 5 units to 7 units here. All right, whereas $5 to $7 here. Okay. Well, actually, it's like 5 units because it's 5 groups of however many dollars and 7 groups of however many dollars. Okay, for the total of Kim and Jessie. All right. But now going forward, whenever it refers to Kimberly or Jesse, we're going to refer to the simplified number here that we have determined already, so we don't have to simplify again later, all right? Okay, so let's look at 10. How many times the amount of money Kimberly has is the amount of money Jesse has? So again, how would we answer the question? Jesse's amount is a fraction times Kimberly's amount. Okay, right? So I just wrote it even shorter than what I said, okay? So Jesse is, so this means this goes in the, Jesse's amount goes in the numerator, Kimberly's amount goes in the denominator, and remember from here, okay? Jesse is 5, Kimberly is 7, okay? So Jesse is 5, Kimberly is 7. Okay, so Jesse is 5, 7. Jesse's amount is 5, 7 times Kimberly's amount. Okay, all right, and let's look at number 11. How many times the amount of money Jesse has is the amount of money Kimberly has? We would answer it as Kimberly's amount is a fraction times Jesse's amount. Okay, so I wrote it like this. Okay, so something times something fraction times something else. Okay, so Kimberly's amount goes here in the numerator, Jesse's amount goes here in the denominator, and Kimberly's amount was 7, Jesse's was 5, like this. Okay, so Kimberly's amount is 7/5 times Jesse's amount. Okay. All right, let's look at 12. How many times the total amount of money they have altogether is the amount of money Jesse has? Gosh, the wording sounds so strange. I don't know, does it sound strange to you? It sounds so strange to me. I'll read it again. How many times the total amount of money they have altogether is the amount of money Jesse has? So how would we answer? Jesse's amount is a fraction times the total. Okay? Like this. Okay? So Jesse's amount, okay, goes in the numerator, the total goes in the denominator, and Jesse's amount is 5. Okay, the total is 5 plus 7, which would equal 12. Okay, so it's 5/12. Okay, so Jesse's amount is 5/12 times the total amount. Okay, and then the last one there says how many times the amount of money Kimberly has is the total amount of money they have all together. Okay, I'm gonna grab my board because it fell on the floor. Okay. So how would we answer that question? Okay, we would say the total amount of money is a fraction times Kimberly's amount. Okay, like this. Okay, so the total is, so that goes in the numerator, Kim goes in the denominator. The total was 12 and Kim's amount was 7, like this. Okay, so the total is 12/7 times Kim's amount. All right? All right. Oops. That's all for today. See you Thursday. Bye.